Greetings everyone, and welcome to Keeping Up with Papa Life After Work, where we find out how one man manages to keep himself busy, physically active, and mentally engaged after retirement with projects. Today's project? Well, we have been building a deck now for the last 4+ weeks, and it's time to put up the railing. What kind of railing? Not just any railing. This is going to be wire railing. First time I've ever done it. Check it out. When April, May. So, we have adhesive wash. This is a washer and adhesive you should put on the back. Trying to get into the third time on this time. Louisiana. I probably used to with the on. Following morning, by the way, okay? Welcome back, and let me give you a little bit of backstory. If you've seen the previous video on the deck build, you know that we completed the deck just recently, and it's now time to put up the railing system. And we've decided, in this case, to go with a wire railing system versus the standard balusters, like you see here, that are on the rest of the deck for this particular neighbor of mine. Why? Well, this area behind me is what he calls his perch. And he likes to sit up here during the day and just look out over the lake and take everything in. And putting in wooden balusters and a wooden top rail takes away from the view. Wire railing, we decided, and by the way, we decided about halfway into the project to do wire railing, we decided that would give a lot more visibility to sitting here and looking out over the lake area. This area right here, I had originally intended just to put a wooden post in and to run vertical balusters all the way across. When we decided to go to wire, we realized that that big 4x4 post could be replaced by a 2x2 metal post, which would be less obtrusive to the view. And so we now have a hybrid system, wooden post and metal post combined. There are only 3 metal posts altogether, one here, one over here in front of me, and there'll be one off here to the side as well. This does, by the way, create a few complications, mainly on spacing for the wire, which is firmly committed by what's pre-drilled in these posts, and by the height of the wooden posts, which were predetermined because we added onto an existing deck. So we had to use the same height post across the board. This post is taller than these posts, meaning I will have to cut, about 1.5 inches off of this 36-inch post, and it's stainless steel. That's not going to be fun, but we have figured that one out. So the wire system we went with is from a company called Muzata. I found them online, and they've been very, very helpful. You simply sent them a drawing of the whole arrangement. They came up with the best system for this application, which they have numerous different ways that you could do this. And then from the drawing, they calculated exactly how many feet of wire, how many different fittings were required, and I just kind of double-checked their work, and it all seems that it worked out pretty well. And honestly, it wasn't really all that expensive. Now, I'll admit that I spent 4 hours out here yesterday just going through all of this and doing a test railing, which you may be able to see over here behind me, to make sure I understood exactly how the process worked. I did find that it was conceptually very, very simple, and I like the way it goes together. There are some minor details where their instructions in the real world don't quite mesh together, and we'll go over those as we get into it. Let's get started. Here are all the components involved in the system. You've got, and Muzata supplies you with a couple of drill bits and everything you see here. These ferrules, and they're just called protector sleeves. They have them in a straight version and an angled version. These are dress rings that go on the terminal post end to just kind of dress off the hole that you'll have exposed when you use these, which are the tensioners. So the way it works is you take your wire, do all your drilling, you feed this tensioner onto the wire, Then you feed this sleeve onto the wire and you crimp this using the crimp tool onto the very end of the wire. The tensioner comes back and hits it there. And then this screws into the hole that you have drilled into your terminal post. You repeat the same process on the other end, but you measure your wire and you cut very carefully and then screw that in. Conceptually, it's a very simple process. They do offer a nice set of instructions. Some of the dimensions on the instructions are simply not accurate. And this is a trial and error thing where I've had to learn it, and I've done a test run already to make sure that I knew what I was doing before I got into the meat of this entire project. That's how all of it works. Let's get started. Sidebar, and an important one. It's time for show and tell, and maybe more importantly, lessons learned. Much of the time with a YouTube channel like this, you'll watch the entire video and pick up things as it goes along. Well, this is a long video, so I thought I would approach this a little bit differently. I'm going to let you know what I learned throughout the construction phase of this project. And then, if you choose to, you can watch the balance of the video and see how I learned each of those lessons. Ferrule location. These are the ferrules. They slip over the end of the wire. You need to crimp that where this is butted up directly to the end of the wire. Not like this. Completely changes the depth that this goes into the hole otherwise. So when you crimp it to that effect without really any wire brush on the back end. Hole depth for the retainers or the screw-in sleeves. The instructions call out 1 37/64 inch deep holes. Well, I read that as 37/64, which is about 3/4 of an inch. Kind of a strange dimension. Actually says 1 37/64, so 1 3/4. This dimension from here to here is about an inch. You add the ferrule, you've added another 3/8 or so of an inch. So if you do an inch and 3/4 depth, you've got the ability to drive this in a little deeper if you need to. So be sure to give yourself some working room on the depth of the hole. Cutting your wire to the correct length. I have cut 227 lengths of wire to do this cabling system for this deck. That's a lot of cuts. And I was cutting each and every one of those about 3 inches longer. By the time you take 3 inches and 227 times, it adds up to 50 or so feet of wire that was dropped or wasted each time. In this case, that seemed to put me over the edge. I had to order more wire. Wire continues to stretch after you've installed it. You can see it even here, and I tightened all this up, that one in particular, a week ago, and it's loose again. So just keep in mind that after you're done, you're going to have to come back at some point and completely retighten every single wire on the entire deck, because they all will have stretched just a little bit. Your washers, the holes in these washers are punched, and so you have a bevel that occurs. There's a bump on the outside and an indent on the inside. You want that indent to be up against the face of the wood, okay? Not the other way around, because physically it won't nest as well up against the wood with this bump on the inside. And also it looks better if you flipped it around and it's like this with the bump out. It just visually looks better. Also, be absolutely certain when you put the washer in place, you stick these little stickers on the back, that when you put the washers on the wire, that you end up with it going up against the post that way and not this way. There's glue underneath here. What good does the glue do you if it's pointed outward? Where you have angled wires coming into a wooden post, drill them also at an angle. Don't drill them straight. If you drill them straight, the wire will come out just a little bit and then flip up, and it's unattractive. So make sure you drill your post at an angle when you have angled wires. If possible, use a cap railing going from post to post to post. Why? It helps to stabilize the post so that when you tighten those wires, you don't pull the post in towards each other. We have no cap railing here, and the result is that my wooden posts have had a tendency to move in a little bit as I tighten, and it creates more wire slack and a lot of adjusting of wires. On the other hand, not having a cap railing gives you much greater visibility off your deck. One thing I didn't figure out until the very end, if you leave your wire in the packaging in a coiled up loop like this, you kind of cut an X, and then you can just actually pull the wire out as you need it, and you don't get this rat's nest everywhere. It's made things a lot simpler on my final bag of wire. One more comment, make sure you have a good pair of wire cutters. Muzata sells a set. I'm not sure if they're any good or not. I got these at Ace, and they lasted about 3/4 of the way through the project before they started getting dull. You want something that's rounded and makes a very clean and circular cut along the cable so you don't have any loose strands. Be cautious screwing these in and out too much. You've basically threaded the hole with this when you're installing it, and as you back it out and rethread it and back it out and rethread it, you'll weaken those threads. I mean, it's just wood, and eventually you'll strip it out. Well, if you do strip it out, you have a couple of things that you can do. One is you can just drill a little bit deeper and get a good bite, and that's what I ended up doing in 2 instances. Conceivably, you could put a dowel in there and glue it and then re-drill it, and that might actually work. I don't have a lot of confidence that would last really well. So the re-drilling is the way I went about it. It seemed to work fine. Just be careful not to pull these in and out too much. Well, that pretty well covers it. Let's get to work. All right, package opening time. Kind of feels like Christmas Day in April or May. So we have wire, and we have post, and we have related hardware for running the wire through the post. The question now I have is 2 things. One, these posts are a little bit too long. This is the base down here that goes in the ground. The top up here is typically, a railing is screwed into it. We're not going to use that system, so we're going to need to cut this off up here somewhere, meaning we have to cut a stainless steel post. We also need to clip stainless steel wire. Now, I didn't order a wire cutter from the company because I have a good wire cutter, what at least I think is a good wire cutter. We're going to find out if it'll cut this wire or not right now. Okay, this is stainless, and stainless is not easy to cut. Let's see. Worked. The biggest thing I was concerned about was a lot of spreading of strands. Didn't happen. This has to go inside of a metal sleeve to get crimped. If it was all splayed out, it would make life very difficult. So that actually works. It doesn't work great, but it's completely doable. Good news. So for the wire railing system, we're using a company called Muzata that I found online. They come very well recommended. It looks like they have fantastic products. We're doing a hybrid system, which means that I've got wooden posts, and because we would like to have very little visibility blockage off of here down towards the lake, we decided for our center post to use metal post. And we have three locations where that's supposed to happen. This right here being the first one. This is their instruction set up for wooden posts. One side of it is for the straight runs between posts, and one is for angle going downstairs. It is pretty much understandable without too much of a problem. I have to admit, I've taken a good hour and a half this morning just to make sure that I really understood what all the components are and exactly how they work. They supply you with 2 drill bits, and they tell you to drill a 9/32 inch hole through the intermediate post. So basically you have your anchor post on the ends, and you have an intermediate post in the middle. Now, our intermediate post in 3 locations will be the Muzata metal post. On the other locations where I need them, there's only one line over here that's got 2 posts in it, and one directly underneath this that's a wooden post as well. Those will be a total of 3 wooden posts where you have feed-throughs that go all the way through. And I bought these under the assumption that they would be drilled exactly on 3-inch centers like it says in the notes that I read. Well, they're not. They're drilled on 3 1/8 inch centers with some variation on that. So there are 10 holes drilled, so by the time you get down to this end and adding 1/8 of an inch, you've added over an inch of distance that I wasn't actually accounting for initially. It's still going to work, but just barely. Also, we'll be cutting off the end of this to match the posts that are here, because it's 36 inches. It's a little bit too long. And actually, I take it back. These posts are 34 3/4. I guess they're allowing for a 36-inch overall height when the railing's on the top. So what I've done is I have drilled a template based on this. I originally set it out, I was just going to sit this on top of it and poke a little hole through it. I decided not to do that. I needed to account for this flange thickness down here. So I just took a measurement, ended up being a 3 3/8 of an inch on all of these, and I pre-drilled. So I will take this template now, lay it up against the post, and simply take the drill bit that came with it and mark my post. Let's drill some holes. There is a top and a bottom to the template, and I have it marked. Some people online were clamping these. I don't much see the point. Also, I will, as I continue to drill, wallow this out a little bit. But it doesn't have to be that incredibly accurate. There you go, 10 holes, all at the right height. In the case of the intermediate holes, you have to drill all the way through. Now, if I were to just point, aim, and shoot and drill with this, I'd be off when I came out the other side. So, neat little trick I saw online was to drill halfway through one side, halfway through the other side, and you will feel your drill bit meet in the middle. And I have done so at this first one as a test, and it absolutely came out perfect. And I put in these little pieces that come from Muzata. The only challenge is making sure you're level and angled properly. And that's just done via eyeball. It'd be nice to have the jig they sell. I'm going in about halfway. See what happens on the other side. There you go. It found the other hole. I don't really want to come all the way out the other side because I'm going to be at a slight angle in there, and I may punch a hole over here and fatten that too much, where this little dress piece, this sleeve, won't fit well. So I'm just making sure it's nice and clean. At that point I know the wire will fit through, and we'll pop those pieces in. I think it's going to work great. This probably isn't necessary. There you go. Well, now it's time for the terminal post. The way this works is they have this piece which is called a cable tensioner, and you drill a hole and they supply the drill bit for it into here a certain depth, and before you install it, the wire will slip inside of that, and then there's a ferrule here that will crimp on that wire, and that ferrule is about 1/4 inch long. And then you will crimp that ferrule in place. Then the whole thing goes in, and you have a tool here which put that in place, and you'll screw that in. Using the template, we marked where every single hole goes for the terminal drill bit, and now Jeff is drilling that down to the proper depth. Well, using one of my favorite phrases, the learning curve continues. Got these two in place. They were spaced properly this time. Very happy with the spacing. What happens when you pull one in, the other one loosens up, and you have this much wobble on this post. Now this post is a free hanging post. It's not part of a post that goes all the way down to the ground. So it gives a little bit. This one does not give at all. So what I've decided to do is go underneath here where this is currently lag bolted to a joist, And we're going to put in some regular bolts all the way through and pull it down really nice and tight and snug and try and get rid of some of that. But we have an inherent issue here that I haven't discussed yet, and that is the fact that usually when you're putting up wire, you have a rail that runs from the top of post A to the top of post B. And that rail stops you from having wobbling occur between these posts or pulling in occur. What's going to happen now, we've got 2, 3, 4, 5, 6, 7, 8, we've got 9, 10 of these wires running from here to here, and every time I tighten one, it's going to pull this post in more and continue to loosen the other ones because we don't have a top rail guaranteeing that the spacing at the top remains the same. I'm not entirely sure how we're going to deal with that just yet. We do not want to put a top rail here. I guess the first thing to do is to see if we can lock these posts down a little bit so this wiggle goes away. Okay, went underneath and put in some bolts, and everything is snugged up really nice and tight. Bolts are in, we did some extra shimming. This is much sturdier than it was previously, and I've got taut wires here. We're going to go ahead and put in the other 8 wires and just lightly tighten them all and see what effect it has on this. Worst case scenario, I can get under there with another set of shims and drive it up, and just one little final bit of tension in this direction on this post, and we got her covered. This is going to work. All right, got this one put in, and it is flush now, and the cutoff was 1 inch of wire going inside the hole. Perfect. So we figured out something important here is that if we don't put these little washers in place,
What's happening here?
well, we thought we figured out something. Trying that again for the 3rd time on this wire. We had it loose, then we had it loose again after clipping it off.
No problem.
Now what's not going in?
Nope, it's all been beveled out.
The wood has?
Yep.
Alright, crisis averted. So snug on there. See if you can get that the rest of the way, just a tiny bit with the tool. Crisis not averted.
Okay.
Is it biting okay?
Yep.
Yeah, so that one's biting. Don't get it too tight. It'll pull out. So we ended up with 1, 2, 3 that are actually too short. Got to redo those. The beauty of having one a little bit too long, we found out, is you can now continue to drive this in as long as you don't put this in place first and tighten it up. Well, 4 hours later, we have 10 wires installed, and that's it. A lot of learning here. Still need to go back and put all these in place where they belong. Won't take a moment to do that. We do have 1 wire that is coming out right here. This one's a little loose, need to tighten it up. And I've got to fill in the wood a little bit so this will go in place and stay. Or else I'll just cut a new wire a little bit longer, drill the hole a little deeper, and make sure that goes down and has a good bite. See which one of those 2 works first. It's the following morning. Let's see how we do. So I have pre-drilled 2 posts. I have cut wires to length, maybe about an inch, inch and a half longer than they need to be. I have crimped a ferrule onto one end, and then I have slid a tensioner in place and then screwed those in to this post here, terminal post A. Terminal post B over here, we will cut to the proper length, which I believe I had that down now, and we're going to try and see if what I learned yesterday is paying off today. Wire number 1 is in, and based on what we learned yesterday, this went very, very smoothly. So to reiterate, what I did was I crimped this end and I screwed this tensioner in flush, right? Then I crimped this in and screwed it in flush, and it's nice and snug. The challenge is, how long do you cut this wire? You can see I've cut this wire quite a bit too long for the application. So what I ended up doing, and this again is based on experience from yesterday, is I pulled this taut level with the hole and I marked it, all right? like that. That's my baseline mark. That's actually a little bit, it'll go in a little bit deeper when it swings over to where this hole is, but it's a good guideline. If I cut an inch back in this direction, you'll see that this tensioner is 3/4 of an inch long. This sleeve, this ferrule sleeve, is 1/4 of an inch long. That's 1 full inch. Well, theoretically, it'll come in nice and flush. Doesn't necessarily work the way you think it's going to work. So to allow for a little bit of extra depth to go into the post, instead of drilling it really what is roughly 1.25 inches on the instructions, I'm drilling it down to 1.5 inches. It gives me a little bit of moving room where if I'm a little bit slack on here, I can drive both ends in and take that slack up. What I can't afford to do is cut the wire too short. If I cut it too short, these tensioners, the face of the tensioner then sticks out beyond this, and this nice little cover piece will no longer work properly. It won't stick to the wood. So here's wire number 2, second wire into the line. We need to apply 2 of these dress washers, and I've finally decided when they punch them, there's a bump on the outside and a depression on the inside. I want that depression to be on the inside and the bump to be on the outside. If it's flat like that, that works great. If you put that in, it's not really flush. If you put that bump in towards the wood. And these are subtleties that you pick up as you work on this thing. So this goes on that side, okay, like so. That will peel off later. This backside will peel off later and puts a little coat of adhesive on there and allows it to stick to the wood. It looks pretty when it's done. Same thing here. I want the bevel to be to the inside. It's easier said than done. That will go like that. And the tensioners will go on. You have to have a clean cut on the end of this wire, else you just can't slip anything on. If you've got any loose pieces of wire hanging out there, it can be quite a challenge to get this in place, this being the ferrule. Okay. So everything's in place as it needs to be. Now, I'm going to line this up and just double check. So the interesting part is here I do have a pole that's torqued a little bit to one side. So this mark is in a different spot on this side of the pole from the other side of the pole. And I'm just going to make a second mark and then split the difference. So we decided to go 1 1/8 inches, right? So just take a 1 inch mark in the middle of this. Come over here, that's 1 inch, that's about 1 1/8 inches. That is where I will make my cut. Nice clean cut on the end. Ferrule's in place. And if I bring this over here, is it bottoming out? No, it's not bottoming out. It's just shy of bottoming out. And just for grins, we'll compare that to the length of my drill. Really got about 1/4 inch extra. That's good news. Alright, dies and crimper. Something else you've got to be particular about is where you crimp this ferrule. You've designed it. If you crimp the ferrule down here, everything's messed up. It's got to be right flush with this head, with the tip of the wire, excuse me. So what I've been doing is pre-closing crimper down to just where the ferrule will fit inside that slot. Okay, and then actually then I closed it a little bit too much. Open it back up just a touch, and get the ferrule nested. And that is, by the way, called a nest in those dies. If you see here, I'm too long. So I've got to bring this up to where it's right at the end. And then crimp. You want to crimp pretty much until the dies bottom out. Open that up a little bit. You don't need to open this all the way up. If you do, the dies will fall back out. And then getting this out is a challenge sometimes. Okay, if we've done everything properly, this is going to work. Pretty sharp, by the way. Be careful not to grab a hold of that and cut your fingers. This tool's an interesting design. It certainly works well. It's just kind of awkward to use. And it looks like I have a huge amount of slack here. For all I know I do, I may have made a bad cut. Getting pretty close and not really tightening up. So I'm basically flush, and I've got that much line there. So by adding that 1/8 of an inch, I'm off a bit. So let's see if my theory of being able to drive that down a little deeper is going to get rid of that slack. I'll probably do it on both ends. Look at that. Okay? That one's snug. So make sure this is nested all the way. You can't see this one, but I'm turning it and tightening it up a bit. Perfect. Absolutely perfect. Worked great. So 1 1/8 inches beyond my mark gets me exactly what I need. Careful where you crimp that ferrule. If you crimp it too far in, all of a sudden your dimensions are off. Just got to make it flush. Very happy with that. That worked out great. Let's do the next 8. One more thing to mention, and that is I will not peel the backs off of these and stick them in place until they're all done. I just want to make absolutely certain everything is accurately coming together the way I want it to come together before I make that commitment. Because once you've got them on there, you're going to kind of mess them up, taking them back off and then putting them back. I just don't really want to stick real well. Jeff had the idea for the little kit here to hold things in. That's a great idea. It works real well. Alright, I'm going to show you this because it's important that I show my errors along with all my successes. And the error here is I put this on backwards. Completely, just totally upside down backwards. So this end needs to be down there. Which then means I cannot use this wire. I'll have to replace it. Perhaps I can use it somewhere else. This is scrap. This wire is scrap. But this is not scrap. This is not scrap. This is not scrap. I'm losing basically 2 ferrules in a piece of wire when I make an error. It's not that big of a deal. You get a lot of extra ferrules, and in this case I probably have 400 feet of wire I had to buy above and beyond because it comes in 500-foot reels. I needed about 600 or 700 feet of wire, and I have, I don't know, 300 feet of wire left over. And now I'm flush and I have that much slack left, but I have the ability to drive this in a little farther. Perfect. So every time you tighten one too much, it loosens the others, and that's where I just want to get them kind of snug at this point. Now I'm going to come back and tighten them all at one time. Success! All 10 are in, and it's taken me probably an hour and a half. I'm learning. I'm getting a little bit faster as I go. Now the trick is to get them tight. I had to re-anchor this post because it was just not well anchored at all. Now it's nice and solid. I started at the bottom and worked my way up, and it's interesting because when you tighten one, it'll loosen the ones below it. I'm not quite sure exactly how that works, but it's pulling this post in to some degree. So the kind of what I have to do is make some decisions and slowly but surely tighten one, and then tighten another, and then tighten another, until they kind of get where you want them. All right, an hour and a half compared to 4.5 hours yesterday, somewhere between 4 and 5. I think I'm getting a little better at it. This represents about 6 hours worth of work this morning. Not everything was working on the wire railing. I had other things that happened in between. But I'm actually pleased with this, believe it or not. It doesn't seem like a lot was done, but a tremendous amount actually was done, particularly proving out a few of the small points that are construction oriented. I don't have all the little tabs put in place. You can see them kind of wiggling in the wind a little bit there. But the top caps are on, and it looks really, really good. The biggest challenge that I think I have is kind of down here on this end. This post wants to move. Every time I tighten the top wires up, it pulls that post in a little bit more and a little bit more. And I've done everything I can to secure it and stop it from moving. So because of that, I cannot really get these super tight. Unfortunately, that's just the way it's going to have to be. So the pole mounts to the floor and into a brace underneath. Well, directly underneath here was this 4x4, which is 3.5 by 3.5, and the dimensions of the spacing on the base plate for the pole are slightly wider than that. So we've had to come in here and sister a couple of bores to the side so that when we drill from the top, we actually hit some meat other than just the deck boards up top. Here's the base plate for the post and the pattern that we drilled. It took Jeff about 30 seconds to go over the system I was using yesterday, and he's now off and running and has this figured out. These posts, these terminal posts, are solid all the way down to the ground, so they don't move like the other ones do that were just mounted to the rim joist underneath. So we can get really nice tight wires on these end cables. Looking good. So we did not realize what all these grommets are for that came with this until the last minute. So sure enough, they go in the holes in these posts. So 5 lines were already strung, so Jeff figured out you could just split one side and pop them in, and you'd never know that you missed them. And we went ahead and put the other ones up top here on the ones that had not yet been strung. And this section is pretty much done. Everything is nice and tight. Wires are taut for a change because we have solid posts on each side. We have a metal post in between, stainless steel, which of course you saw us cut off earlier. And a cap will go on top of that, and caps will go on these other 2 posts. And that section will be done. It really, really looks good. One quick tip, put the base plate in place before you put all the grommets on, otherwise you have to remove a bunch of grommets to get the base plate back on. Also make sure you put the base plate on before you put the wires through the holes. So these poles also need to be 32.5 inches tall. So we've marked the end of the post at 32.5 inches with a line. And the question becomes, how do you cut stainless steel? It's not easy to cut. Well, you could do it with a grinder. That would work just fine. You could put it on a chop saw and use a blade designed for stainless. Or you could get a Sawzall, yeah. Or you could get a Sawzall. And they make a special blade for stainless, and this works remarkably well. So I'll try and stay out of the way so you can see this thing cut. We put a towel down, by the way, to protect this, because otherwise we'd be scratching it up on the post. And perfect.
Presto.
It is a two-man job, by the way, and I was trying to think of reciprocating saw. You may note this is not a perfectly even cut. Caps are going on. The caps will hide anything that's not beautiful. Something to consider when you're dealing with your wire is that it is not on a spool. It is just loose, and it becomes a rat's nest. For the next roll, I think I'm going to figure out some way to rig a spooler so that it stays in place and we can just pull it off. So as with this first large section, we cut all the wires to length first. Jeff is now crimping the end on the first terminal post. We'll run it through, making sure all the grommets are in place on the metal post, making sure all the little washers are in place to seal up here on the terminal post, and then terminate the other end. Ends up being a very simple system. It's just time consuming. So Jeff is finishing up over here with the last 4 wires on that edge over there, and the homeowner's come out and taken a look at it, and he absolutely loves it. He particularly likes the black post in contrast to all the brown. So he has asked if we can paint all the posts, the wooden posts, black as well. Well, it would look really good, and the answer is yes, we can. It'll probably require us to either tape off around the post, but most likely what we will do is pull the lines back out, paint that face, and then put the lines back. Doesn't take too long. There's much less chance of us getting paint all over the wires if we move them. So that will happen next. There's a whole section down here that has no wires on it yet. We will get these posts painted and then move back in this direction and paint these posts. So at this point, it kind of goes without saying, it really would have been nice to have known we were going to do this up front, because we would have painted all the posts before we put some of these wires up. About half the wires are up in place. And so what we're going to end up doing is these little stick-ons here, these washers, we will have to pop these off, slide them down. We wrap this with, we wrap all this right in here with some painter's tape just to keep from getting paint on the wire. And then we will put these back, and hopefully they stick just fine after having been removed. Look at that big spill. Good thing I taped it. Okay. Looks good. Give it about 2 hours to dry, and then we'll remove all the tape and slide these guys back and put the cap back on. It'll be pretty. I have 8 more posts that need this same treatment. All but one are mid-run posts or terminal posts with 2 wires in them. This is going to take a few minutes. Point of interest. That was tight 3 or 4 days ago when I left it. It's loose now. These boards haven't moved. I guess the wire stretches a little bit. And I'll state it again for the record. these would be nice and tight with the top rail. But top rail is not in the cards for this project. Go get that for me, will you? Thanks, I appreciate it. Alright, that one's snug. This one's pretty well recessed back in there already. Maybe bottomed out, but the other end won't be. This is a huge amount of slack. I actually could probably pull this out, cut that tip off, and crimp it back again. I may have to do that because this is so much slack. These other ones aren't quite as bad. But for some reason that top one really stretched out. The upper deck area is finished. All the tape has been cleaned off. I hope anyway. Everything is painted and it looks really good. I have some small caps that I put on top of the metal posts. Those still need to be permanently attached with some silicone glue material, some caulking basically. That's about it. All right. Tomorrow we start painting all the rest of the posts on the lower deck. Back at it. So this morning we're working on a section over here that has some steps that come down. So I have pre-drilled all the posts, and then I've run a wire from point A to point B, kind of middle of post to middle of post, taken a measurement, and then added about 2 or 3 inches to it and cut them to length. I then crimped on the ferrule at the end, and then slipped the tensioner in place. And I've done that for all 10 wires, and now we're going to start installing those wires between those 2 posts. So we're screwed in on this side. On this side you can see I'm cut quite a bit further. So what I was doing previously is coming along here, lining up with the hole, pulling it taut, and then marking it right at this surface right here. The difficulty here is this post. I should never have used this post. It's torqued at the top a little bit in, so I'm going to have a different dimension from this side to this side. So I'm just kind of making a best guess as to where that middle is. So right about there, I'd say. So that is my starting point. Then I want to be about 1 inch in from that where I make my cut. So we actually put a mark on this little tool. It's Jeff's idea for repeatability. And so there's the mark on the wire and the mark on the tool and a mark right here. And that's where I make my cut. That's got a lot of slack. In a case like this, if I've got really a whole lot of slack, I can pull one end out, cut the ferrule off, and re-crimp it. This one, perhaps, will need that done later. We'll see. All in all, I think it looks pretty good, just like we expected it to. It is a step down, so it's going to be on an angle. The next one over here will be straight across, and then this will all be on an angle following the steps down. Exactly like I expected it to look. I'm pleased. Following morning, progress being made. We're over to here and working these corners. I'm doing a lot of prep work. Jeff's doing the final crimps. Got really hot outside and full sun for a while, so I brought in a couple of fans. They help a lot. For a while now, I've been considering how to deal with these corners on where we have an angle coming from post A to post B. What finally decided to end up doing was to drill on the outside edge, and what normally would be dead center, that you see here, I'm pulling it over to 2 inches in from this edge. And what that does is it gives me a little more meat here up top, because we're drilling in at an angle across like this. This shows that pretty well. It's actually working pretty good. It's a little better example to get the penetration that we need, I'm going that far into the post. So that's why I pulled it from here over to here, just to have a little more meat there, and so we didn't punch through to the other side. Again, working really well. This is how it looks up close on the finished product. As you can see, it's at an angle, but with that little washer on there, eventually it'll dress off nicely. Productive day today, about 5 hours of labor for 2 people actually. And we've got that section, this section, and this section done. Now, 5 hours sounds like a long time, and honestly, it's longer than I think it would take. I have to admit, I was doing other stuff in between, and this is very time consuming, and we are not doing it inefficiently. We're doing a very efficient job of it right now. And it just takes time. That's kind of all there is to it. But it looks really, really good when it's done. These 45-degree post angles here deserve a little bit of special discussion. There's something of a challenge. Let me show you one that's not completed. Now, in addition to drilling, which I've already discussed, the real challenge here is where to cut the wire. Normally, if the wire is coming up to a flat surface, I can very easily visualize where I want to cut my wire. I actually put 2 marks on there. I put one for the surface of the board, and 1 an inch in to where I want to put the ferrule that I crimp. In this case, I can't do that. It's holes over here, that's over there, and so it gets to be a bit of a challenge. And after having done this section, Jeff did the other section, I finally kind of figured out that if I stand up like this and just kind of mentally draw a line across to the center of the hole, or a little bit to the rear of the center of the hole, I get a good cut, a good clean cut. I'm going a little deeper in most cases than I would like. It's working out well, with the exception of this one. This one I tried something a little bit different, and it's not going all the way in. Now, it's not completely tight just yet, but I have tightened it once already, and I'm going to give it overnight and let it stretch. If it doesn't stretch out to where I can actually use it, I'll take it out, use it somewhere else, and replace it. You will likely slice up your fingers a little bit on this from time to time. I probably should be wearing some kind of work gloves. I haven't really had a problem with it yet, but Jeff has been having issues with slicing his fingers. Well, I seem to have received a visit from a very unwelcome visitor. That would be someone that shows up at all my projects, and his name is Murphy. You know, what can go wrong will go wrong. It turns out that I used this template on both sides of this post, as I would normally do. Set it here, and it lines up pretty good. Problem is that down here on the floor, something that I did not notice, that would be that this board right here is high on this side. So I set the board on that board, and it raised every one of these wires up by about 3/8 of an inch. The result is that this wire is lower than this wire all the way down. And it's pretty obvious, at least to me it is. Now, a lot of people probably wouldn't care one way or the other, but it bothers me. And if I can fix it, I think the only way to do it would be to pull these wires out, buy an appropriate sized dowel, and glue that dowel piece into the hole, give it 48 hours to set, and then re-drill it. The only question is, will a dowel hold these tensioners? So far, that's the only big screw up. Lots of progress has been made. The railing, wire railing for the upper deck is completed. The wire railing for the lower deck is completed. And now it's time to run the wire railing down the steps, which go down to the ground from the lower deck. So this gets complicated because there's a lot of angles involved. You have to figure out exactly the angle you're coming down here. You have to drill these holes for the retaining screws, whatever they're called, into the post. and at the correct angle, or at least as close as possible to the angle you have for the step down here, so you don't have a wire coming out straight and then bending and going down. And you have to determine your hole locations. Well, of course I have a template, and the template works really well when we're dealing with something that is straight like this and coming out of the post. But when we're dealing with something coming downhill like this and trying to mimic this rim joist on the steps, it gets a little more complicated. Let me show you. What you run into is a potential alignment problem between this rim joist and the wires coming down. Now it's really just visual. It doesn't affect the performance or the function of the wire railing, but it doesn't look right if you've got a point here where your wire railing is this far above and you've got a point up top where it's only that far above these corners of the steps. Now the first one that I did was my guide. I did a very good job on that, or so I thought. I took a hard look at it this morning, just thinking my way through all this, and realized that I had one height here and a lower height down lower, and you only saw that if you got down low and took a look. But it does in fact make a difference visually. Mainly to me. I don't think anyone else will ever notice it unless I tell them about it. So in this case I want to get that exactly correct. So what I did this time was I took a straight edge and I lined it up with the hole I had marked over here for my first drilling, because I knew that one would be accurate. And then I moved this up and down, and I really just kind of visually stood back. You know, down here obviously is way too low, up here is way too high. And I just took a step back, and voila, there it was. That was my point that I needed in order for me to have a nice straight line between the wire that would be coming down and this stair rim joist here. So I marked that. I had originally set it up with this and did a little drill marking. It was too low. So I redid it with this once I had a new mark, and ended up having to raise it up 3/4 of an inch all the way up. Not a big deal, but I'm glad I did it now, because later on it would have driven me crazy just walking up to the steps and seeing this little bit of alignment variation that simply didn't need to be there, just by taking a little more time to figure out my angles. This is pretty much eyeballing this to figure out exactly how to drill it. I've got to come in on this plane, you know, and be this way, excuse me, on this plane and not be cocked this way or this way. Now I've got to come in on this plane and be roughly matching what I have down here below. That's hard. Of course I use a magic marker to mark my depth, which really is just the end of this part of the drill bit. Notice I'm starting it, turning up, and then doing my best to match this angle and drill. I made a mistake on the other side. I'll show you in a moment. Rookie mistake. 1, 2, 3, 4, 5, 6 out of 10 holes drilled straight instead of down at an angle. Just not paying close enough attention. Well, I think I can actually make this work, and the way I'm going to do it is I have a test post over here on the other side that I've drilled some holes in. Whenever I make a screw up of some sort, I'm kind of using that to make sure what I think will fix it will fix it. So in this case, I went over to that test hole and I drilled a hole in like this. Then I drilled a hole in at the correct angle, and then drove in one of the retainers, and sure enough, it just screws right into that angle, no problem. So it creates enough of a new hole going down in at this angle that the retainer has plenty of bite. I will try that on one of these and make sure it works before I do the rest of them. Big question now, is this working? Well, I took the drill. As I said, I drilled on down that angle. I drilled a little bit deeper than I normally would have, and I have sunk this initially a little bit deeper than I normally would have. And then I cut my normal length, and I'm up top where I should be, and I'm just a little bit shy of tight right now. So the question now to be answered is, will this pull out when I tighten it up? Let's give it a shot and see. No. Outstanding. It's working perfectly. If I do have a little issue, I can back that one out some and push this one down a little deeper. I'm happy with that. Looks great. The other important question is, how does the angle of my line look compared to the angle of the stair joist? We got it. That is absolutely perfect. This turned out fine. One of the holes that I had drilled twice, it came out, so I removed that completely and cut a new one. Drove that one down in quite a bit deeper, and it is holding really well. And as mentioned up here, everything's nice and flush, coming out straight, good angle, except the very top one, which has to take a little bend before it comes out. We can live with that. I found these really nice two-piece base covers for the bottom of the 4x4s. Looks nice. Getting real close to the end. I'm working by myself today, so I've set up my own little private system here where I'm cutting all 10 lines and crimping them and then putting in one end, and I'm just going to do that for each section and then come back and do the actual termination cut and putting them in place. 4 more to go here, and then 10, 20, 30, 40, 50, 60, 70, 80 more terminations into wooden post. Yeah, I'll be here for a while. I'm actually a little worried if I'm going to have enough wire or not. This beats the pants out of having a pile of spaghetti down there. 41 inches will do it. These have gotten dull. Not quite as easy to cut. Well, this is the final pre-prep wire that I'll be crimping today. Why? Well, not because I don't want to finish them out, but because I have just run out of wire. Now, Muzata did the math on how much I needed, and I actually checked their math as well. And I really expected to have a lot of wire left over, but I don't have a lot of wire left over. I have about 2 feet, and that's it. Why? Because either they and I both did bad math, or I misordered, or they short shipped me. And I don't really know which one it is just yet. So I've got to go back and look at the invoices and such. I got 2 containers of wire that came in. I was kind of expecting 3. So I'll let you know. And by the way, I'm 3 wires short over here at about 4 feet each, and 7 wires short over there at about 11 feet each. So that's around 100 feet of wire I need to finish the project. Handrails, an absolute necessity for people coming down the stairs. Kind of an awkward setup here, but it actually works really well from the standpoint of being able to have something nice and solid to grab hold of. I do like these rails. They're great. They're very solid. Problem here is we had to stagger them, one high, and one low. There was really no other reasonable way to do that. So it looks a little bit odd. This one on the other end has to be cut off, so they're too long. That one on the other end has to be cut off. It's also a little bit too long. When that's done, it'll look a little less strange, I think. And, you know, if we just don't like it, the worst case scenario is we remove this one entirely. It's not completely, totally needed, but it is kind of nice to have there. I'll let the homeowner make the decision. Here's a little better view of that middle rail. Finally getting very close to the end, and now it's dress off detail work. Small things like, for example, I want to put caps on top of these. Well, I initially tried doing it with some silicone sealant caulk, and that didn't seem to take well. So we're going to fall back on construction glue. Perfect. Now let's see in 24 hours if it's still where it's supposed to be. It already popped up on that corner. More detail. Every single one of these retainers has a washer that goes over it, a dress washer to dress it off. They look really good when they're done. Before I do that, I'm going along to every one of these and giving them just a little last minute snugging. And usually when I hit one, it causes the one next to it to change a little bit too, because it pulls the poles in. These I've already done. They're pretty tight, probably about as tight as they're going to get, and I am happy with them for the most part. So 10 of these rings on each one. It's really easy. You just peel the paper off, slip the ring in place. There's adhesive there, and you're done. Just out of curiosity, I just counted up all the faces on all these poles that had to be drilled. There are 46 separate faces that had to be drilled, front and back. That's 10 per, so that's 460 holes. In addition to that, I had to put these washers on, well, 3 of them, 1, 2, 3 are just feed through, so that's 43 that get washers instead of 46. So 430 washers and 430 points at which I need to tighten and adjust the wire tension. It's a lot of work. I was wondering why I have so much sag after tensioning these initially, and part of it is because the wood moves a little bit. But I looked it up, and cable does tend to stretch after tensioning. Apparently there are 2 types of cable stretch. One is construction stretch, and one is elastic stretch. Elastic stretch is when it stretches and then it eventually pulls itself back to its original length that it was before. Construction stretch is what we're doing here, where you put tension on it and it's completely nice and tight, and it stretches a little bit more after the fact. Eventually you can tighten it enough where that pretty much goes away. At least that's my thought. But that's why I have this when it was nice and snug a couple of days ago. So you are going to be in a position where at some point you're going to need to come back and retighten these wires. Here's an error that is going to cause me some headaches. You'll notice that this retainer sticks out beyond the face of the post. So when I go to put this washer on there, it doesn't go in flat. Same thing has occurred on this one. Now I've managed to get this one to, on the other end, I have managed to pull it out some enough to where I might be able to live with that. But this one I cannot live with. I've loosened the other end out as much as possible before I had the same problem on that end. This likely means that I need to cut a whole new wire. And as previously mentioned, this is why you want to make sure that hole has a little extra depth to it, so you can spin these in a little further when the time comes. Detail work. This is a quirky one that I have no better way to do it for the moment, I think, than to do what I'm about to suggest. Previously mentioned, this wire, this whole series of wires, is up too high in comparison to this wire because the board was up higher down at the bottom when I put the template in place, and it bumped this whole thing up by, close to ½ inch. So I think what I temporarily had put screws in here to level this out, and it's just, I'm not getting any bite on the screw holes going into the post. So what I'm going to do is I've marked where this wire is on here, and I'm going to take my Dremel and I'm going to notch this out so it slips down over that wire. Decent depth. That might work. There's the way it looks on the other side. No one but me will ever know. While I have the grinder out, I have one more problem I have to deal with. When you put the handrail bracket over top of this washer, it pops the washer out like so. I'm going to take an edge off the washer with the grinder and then pop that back in place and see if that works. As usual, I am making this up as I go along. So, grinder, hold it tight with the vice grips. Here we go. That, by the way, is not an aluminum washer. That is stainless steel. Look at that. Perfect. Brilliant. Two interesting things about removing the backing paper off the washers. One is grab it and pull it all the way away before you tear it off. If you pull it off while it's still attached to the washer, half of it sticks. It's a pain in the butt. And the other is, don't put the adhesive on the wrong side when you string the washer onto the cable. It gets a little complicated at that point. I've done it multiple times, and you can do what I'm doing right now. Just scrape off the adhesive and put it on the other side so it sticks. The absolute final step, I think, will be touch-up painting. Here's an example where we're going to have a railing here. We decided against it. I filled it with wood putty, and I'll come back and touch this up. I've got some nicks and cuts all over the place. We have some places on the old boards that are painted brown up on the high deck where it's peeling, paint's peeling. I got to peel that back off and repaint that. Small things, probably take half an hour to get it all done. So this is the handrail. It's got to be cut. It's a little bit too long. I made a pencil mark right here. And they say in the instructions, and this is really obvious, you do this on a chop saw. Well, I do have a very nice miter saw. And I have in here what I'm just going to call a sacrificial blade. I don't really have a blade that's designed for cutting metal at all. So I'm going to cut it with a regular blade. Hopefully, we'll see if it works or not. And that blade, which I've been cutting other metal with in the past, eventually will just go away. Wow, it worked. Now I need to cut these base plates that go around the 4x4s. What I have is an instance where I have a post here and a wall here, a staircase wall, a rim joist. So I have to remove this piece of metal and then be able to screw what's left over in here, and in there. So it'll butt right up against the staircase like that. This is not something I'm looking forward to doing. I don't quite know the best way to approach it. So I'm really thinking of doing this. I don't know why it won't work. The only thing is when I get to the end of this cut, that piece is going to fly off and I'll have to run it down. So let's, I've got a couple extras and see if this works or not. Well, it didn't fly off. Huh. So I should be able, whoops, a little warm, should be able to do this. Wow, how about that? Assembled, looks like this. Installed, looks like this. That is perfect. I will drill a hole here and pop a screw in so this doesn't move around. Very pleased with that, worked out great. Today should be the last day of the job. My 200 feet of wire I needed to finish up came in. Got over to the job site and realized I was short some additional materials, which shocked the heck out of me. Muzata, I've got a bone to pick with you. And here it goes. Wire, okay, that's probably my bad. I haven't done the math yet, but I cut it 2-3 inches off and I did hundreds of terminations. So that added up over the entire length and I could have shorted myself on wire. Washers. There should be one washer for every one of these adhesive stickers. Look at this. I've got 15. I don't know. There's a bunch of them. Right? I don't have any washers. There's one washer left right here. That's it. Retainers. There's only 4 left. They did the math on exactly how many I should get, and there should have been plenty in each bag that came in. Each one of these, which are the ferrules, represents one of the supply bags. And there's 4 of those bags of those left over, plus what's in here. And a bunch of these guys. So I'm not quite sure where the screw up is. In addition, there's a 7 or 8 of these left over. I'm not even sure why they're in the kit. These are for threading metal. I was threading wood. Not needed at all. So now I've got to go and order one more bag of supplies that will have retainers and washers in it. And that'll take about 7 days to get here. So a week from now, I'll finish the job. It's 7 days later, and the package from Muzata showed up just as expected. Took a week. And inside of that package, there are 20 of these cable tensioners, also called screw-in sleeves. I've called them retainers before. There's a bag of ferrules. Don't know how many ferrules there are. There are 20 of these washers. And there are 30 of these stick-on adhesive circles for the back of the washers, along with another drill bit and a socket wrench and another one of those. So how we got so far off, I really just don't know, because this is exactly what I expected when I ordered the package. Something I learned on the last reel of wire so I don't have a rat's nest everywhere. It's easier than setting up some kind of despooler. Just cut the plastic so that it contains the wire. Find the end, and then it pulls right out, and all the rest of the wire you're not using is still held in place by the plastic. Neat trick. And that's it. Another project completed. Let's take a quick look at the final product. Looks pretty good, doesn't it? I have to admit, I'm pleased with this one. As always, questions and comments, and in particular advice, are welcome. Please remember to hit that subscribe button. I'll see you next time on Keeping Up with Papa, Life After Work. Papa out.